G'day guys, got some real interesting stuff for you this time round. Been busy doing some work on the 6000 and the 7000s. Came up with some extra very interesting changes to those detectors. And also we have just received our new components for the GP GPXs, SDs. You can put them in anything actually. It's new devices for the input stages of these detectors. And how about I just show you how well they work in an existing design. Now this detector has come in for some upgrades. It looks brand new to me. It looks like it's never been used. And yeah, it's got those funny stickers on the front. I don't know if that's an overlay or what it is. Oh yeah, it's an overlay. An overlay there, I think. Trying to work out. It starts there, but I don't know where it ends. I don't know. Yes. Oh yeah, okay. This, whatever it is, it's pull all the knobs off and stick it down. So when I look at that, it just confuses me because I'm not used to it. But what we'll do, we'll just get this 4500 just in the room. I have got the computer on. The computer is on over there, and there is, no, you can't see, but up there I've got the battery charger on, charging up one of my lithium packs. But the rest of the workbench is off. So I'll just have a look at the noise situation. It is just past 4 o'clock, which means the dear little kidlets have come home from school, and we'll turn the TV on. So we might have a bit of noise come through. But as I get going on this stuff, I'll explain about the GPX, then I'll get onto the GP 6000, then I'll get onto the GP ZZ 7000. So what we'll do, I'll just turn this thing on and I'll crank the audio up just so we can hear it. I'll get the speaker here. And I'll just set it back to factory default. Okay, factory default. And I'll do a frequency scan for the lowest noise. For some reason, it sounds like there's a lot of noise around today. Now let's put the speaker there. So it's aiming at this microphone. Now it's going to warble and carry on for a bit. But this just came in the door 10 minutes ago, so it just pushed me into doing explanation of everything I've been up to in the last 48 hours. And it is quite interesting. So I've got my test targets here. It's as noisy as all hell. Okay, we've got our test targets here. I'll put my hand there so you can see them. I'm going to use very small targets because I found the performance on small targets just translates into big, deep targets anyway. The gains you get on small target usually means there's probably more decent gains on bigger targets. That's terribly bloody noisy. And I don't know why it's that noisy. This is factory default. You saw me set it up in factory default. Now I'll just turn off my battery charger just in case it's doing something. Minimal. I've never had that much noise from anything before. I don't know what's going on, but we'll see if this noise affects every detector. So what I'll do first, I don't even know what this detector's in, but we'll go on the coil. We'll have a look at it. It's in enhance. It's fixed. It's in cancel mode. Doesn't sound like it, does it? Hang on. I'll stick it in mono. Yeah, okay. It's in cancel mode, but it doesn't sound like it's doing a really good cancel, does it? Okay, it's in enhance. I just have to lean over here. There's that little stick with the little, I'm going to put my hand there so you can see it. Little 0.2 by 1 millimeter piece of copper. Nothing. It doesn't detect it. That's a standard GPX 4500. Now this is the 2 millimeters long by 0.2. I can detect that. About 5 millimeters off the coil. And if it doesn't detect that 3 millimeter piece, I'll flip over backwards. There you go. That's where it starts coming in. So 5, 10, 15, 20 mil, 20 millimeters, not mil. That because Americans will think I'm saying thousandths of an inch. Anyway, I turn that noisy thing off. Gee me, if I can get the plug off. Oh, we'll go back over here again. You can watch me wrestle with the connectors. So yeah, Brendan, this is your detector, and it's as noisy as hell. And as you can see, it's got the original Minelab seal. Like I say, it's just come in the door. What we'll do now, I've got a standard 5000. Okay, and just a standard 5000 detector, and it's used as a reference because I've got STD. It doesn't mean some terrible disease, but that's just standard. So standard Minelab 5000. I will connect him up, and hopefully he's not that noisy because that means something external is giving us a really hard time. I'll even do the connectors up. I'll do it properly. Not that it needs to. If you're not out in the bush swinging, you can just plug them in. It's going to work. It's fine. Okay, now I'll turn this on and I'll put it into factory default. All settings. Okay, less noisy. These detectors do have less gain. Remember that against the 4500. But it's still woofy and carrying on, but it's not as much as the other one. These things have a front end gain of 34. It is not. It's 33 on the resistor scaling, but plus 1, so it's 34. And the 4500s, the later ones are the same as the 5000s, by the way, and the earlier models have a gain of 48. So that gives you the multiplication factor of the input signal. So we'll put it into that. I'll let it do a scan, frequency scan. This is, it's a bit of a time waste because here the noise is pretty uniform across the band. You've got these in cancel mode, so if cancel mode and the coil was beautifully balanced, it should cancel everything out, but it doesn't because there's always errors in the coil design, errors in the matching in the components. So a 5% error in even any sort of tolerance, even resistor tolerance on this, it'll cause havoc with the cancellation circuitry. So we can't have that. Well, normally when you design something, you make it really good. Okay, this is in enhance, all standard, factory standard. So I'll go around the coil, and I'll just drop my number 3. Hang on, come back here. Okay, again, number 1, a little speck on the end there. Let's see how she goes. about 2 millimeters off the coil. But notice how the noise is still absolutely horrendous. Not as bad as on the 45, but still there. Now what I'll do, I'll drop this into normal mode and I'll just give it a frequency scan again. But you want to see how I've got one over just behind this. I've just finished working on it. It's got all new components. They have just come in the door, and I'm going to give you a look-see of how good this goes. These devices in this unit we had manufactured to our specification. So this will be an eye-opener. There's a lot of very, very important aspects, even to semiconductor devices, that it is really, really important to have so many of the specifications spot on, like, and as good as you can get it. Okay, same thing with number one. Whoops. Remember I said about 5,000? You can even get a signal if you scrub the coil. It's just there in the noise. It's not going to stop you on anything. So that's just a dead standard, stock standard 5,000, stock standard 11-inch GP series double D coil. Nothing fantastic. Okay, spin. You want to look at the coil? You want me undoing the connectors again for fun? Okay. Now here it gets interesting, guys. This will really spin you out. Okay, get rid of him. Put him down there. Okay, you can see a circuit board there. Now I'm going to hook this up totally unshielded, not in the box. I'll put the targets down there, and first of all, I'll show you. Okay. Can you see there's new devices on there? I've just put a bit of white over them. So basically the damping MOSFET and 2 input MOSFETs. Are they MOSFETs? Okay. You can ponder about that. Oh, this one also had 2 capacitors here that needed replacing. They were the wrong value on this board, so they have been replaced. Some of these boards did come out at one stage, and the capacitors where my thumb is was wrong, and wrong. These ones are right, actually. These two are wrong. So that's been fixed. Someone actually sent me a copy of the engineering bulletin on that some many years ago. So don't even know who it was. It came anonymously through a made-up Gmail account, so I don't know who that was. Okay, we'll plug him in. We'll give him some power. Now, if you noticed on this one too, I've got none of the mod boards in it. If you look at the front, stock standard. And it's stock standard detector. This was my 4500 standard reference detector, but I thought, well, might as well use the 5000, and we'll try out the new stuff on this because nothing else has been done to it. It's more a proof of concept, and no other fiddling has been done. Now all I've done is put new semiconductor devices in, gains all the same, and I've just done a little bit of rework on the power supply. Reasons for that will become apparent. So what I'll do, I'll turn him on, I'll put him in the factory default. Reset all. Now isn't that nice and quiet? Quieter. I'll say quieter, right? Even though this detector, as far as I remember, has the input gain set higher. So we'll see what happens. I haven't even done a frequency scan yet, but I'll do it. I don't even know what I'm in. We'll see what it is. I'll try and get... the camera and the tripod's in the way. I can't even see what it's in. It's either an enhance or normal. It's one or the other, but I don't know where it was left. So have a listen to this for a standard 4500 that's just had some of the critical semiconductors replaced on the top board and on the bottom board. So I'll just let it howl away there for a bit. Now, there's nothing else done to this. I have changed that damping device there, that FET, for a higher rated one too. That's nothing, it's not going to affect the signal. So what we'll do, we'll get number one. That's number two. Number one, where are you? Okay, we'll turn him around. Okay. Number one spec, you see it there? We'll see, I don't even know, whatever mode it's in, we'll find out in a minute. Now that's definitely an improvement over a stock standard 45. I'll just have a look here, I'll just have a peek. Okay, that was an enhance, but what I'll do, I just flicked it into normal timings. And this is the thing that really interesting, right? Normally on a very tiny piece of gold, you'll get a better signal response in enhance than normal, right? This is what I've noticed over the years. Now this is in normal. I should have probably given it a frequency scan in normal because the timing is different. But I probably should be going across the windings, but anyway. Oops. I mean, it's a bit cramped here at the moment. We'll see how it goes on the two. Really good frequency response. That's in normal timings. And on the three should hammer home. It's pretty good. 3 mil. 3 mil by 0.2 mil. So that's that little beastie running there. What I wanted to point out, the noise. Okay, I'm going to say this. I'm going to be careful what I say. I really have to be careful. This is my opinion, right? And my opinion is that these detectors generate internal noise. And what that does, it mixes and beats and heterodynes with external noise sources coming in, and it makes the situation a lot worse than if you had one or the other, okay? But the noise in this detector is significantly less than that other 4500 and even the 5000. It's far better behaved. So that's a quick, well, it's not really that quick, but that's an easy, straightforward upgrade to these detectors. Okay, I mean, there's nothing about this. It's just bare bones, stock standard. You know, nothing fantastic. That's just the backboard, the display, and this is the input board You can probably see some little black things in there down the bottom. It's had a new 2022 in there as well. And if you can see there, it's got some new devices in there. It absolutely improves the performance. But I haven't done this next one yet, but I'm going to show you something. Remember the detector I have, it's a 4500, it's the one I call no ears, right? I'm going to tell you something funny, and you're going to, well, I actually was in shock. But I think there's a video, and I did a field test on it, and it was working. This is funny. This is really funny. Okay, bear with me on this because I'm going to try and explain it in great detail. I put new boards in this, okay, this one here, and I'm thinking to myself, beauty, I'm going to go and do some tests. So I think one of the videos I did, I don't know, it might be 10 videos ago, but I was out at some new place I went to, and I turned it on, and it was really, really quiet. And I'm going, wow, this is good. And I got the targets and I put it over the coil, and it was giving it a reasonably tongue-tied, a reasonably good result, but it was a little bit soft. It's really hard to explain. And some people picked up and contacted me and said that detector didn't sound right, and I thought nothing more of it. And anyway, it gets quite funny. And the other day I said, yeah, I better have a look at it. I pulled it apart. I said, no, it's all right, it's all right. And then I realised it. I didn't put the ground from the power supply to the board. It was floating on a +5 and a -5 volt rail. It had no ground. How did it work? Right? What, leakage back through the electrolytic capacitors to ground? I don't know. But one thing I did notice when I swung the coil, it had no airfield cancellation, which gave the game away. And I didn't do it out in the bush. I had the coil sitting on the ground. Yeah. So this one now, I put the earth on there, or the ground, should I say, the return. And this is the best detector that I've ever made. This is a bloody beauty. I will hook it up. Now, it has a lot of stuff in it. It will take a minute or two to stabilize. Does it really need a minute or two? Yeah, you could just fire it up, start going. But if you really want the benefits of how this works, you really want to, I hope I've got it sitting in whatever mode it's meant to. Hear that? Woo, 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 like that. Now you listen, that should fade away. There's a hell of a lot of devices equalizing out their currents and voltages. We'll see how we go. I don't even know what mode I've got this thing in at the moment. It's in normal mode. Okay, it's in normal mode. Still got a little bit of noise coming through. It may disappear. I could tweak the frequency. Nah, the noise is wideband. Doesn't make any difference where I put it. It's probably as quiet as it's going to get. But if I do leave it there, it will get quieter. But it does take about 2 minutes to absolutely equalize out. But we'll give you an idea anyway. Now you know how this is in normal mode, by the way. So I'll turn it. That's that one thing. So that I hope you can focus in on that. Let's see what happens. about centimetre, but there's still a little bit of noise coming through, but that's a fair test. The other ones are copying the noise as well. And this is normal mode, not enhanced. So let's have a look here. That's the number 2 Durkin, little dab on there. Well, get it up about there, which is quite a distance. I don't know, 25 or so. 25. Is it probably a bit more than 25 mil? What would it be? Yeah, it could be about that. Now, I'll grab this thing here and I'm going to put this into enhance. So it's in enhance, and I'll use the 1. As I go over, it's dragging the noise up with the signal, makes it very, very hard to hear. I don't know what's making that racket. It's really, I'm thinking, is the camera? It might be the camera, because I was doing tests before and it didn't have it. So let's move it right away. I'm just going to move it way over there. It's still there. I think it's because the kids have come home and whacked on the TV, and that thing is a bucket of dried out capacitor switch mode power supplies in it. It's going to cause a lot of issues. We'll come back to that. I've got the gain halfway, which equates to roughly a standard detector. I mean, it's very easy to shut up. This is why I've got the variable gain on these detectors, because you just do that and you've got no noise, right? So out in the goldfields, if you're getting swamped by over the horizon radar, and I've just been informed that the Chinese are starting to fire up over the horizon radar, as well as the Australian over the horizon radar, all in the HF band, which is going to affect metal detectors, because the signal is going to get reflected back by the ionosphere, and it can end up anywhere in the HF spectrum and smack the hell out of the poor old detector, because they're a wideband receiver. Even standard, the op amps in there will easily cover the spectrum of the HF band. So anything is going to come in, it's going to get amplified. You're going to get whoppity whop 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 noises coming through. Nothing we can do about that. Now, I have got this thing turned down to 0 gain. I'm not going to try it on the 1, but I'll try it on the 2, right? Isn't it funny when you get rid of the noise? So that's on the 2. We'll try the 1 anyway. I'm on enhance and I'm running 10 decibels below normal standard gain. This is 10 dB below, which basically is 10 times. Let's have a look. Got the 1 here. You can see that. The 1. I doubt it'll pick it up. No, it won't pick it up on no gain. It's just too much. But if you're looking for bigger, I'll tell you one thing though. If you're looking for things like on the 3, that's only 3 millimeters long by 0.2. But as soon as the targets become bigger, not a problem. You could go and work in the worst ground ever, right? And the worst atmospherics ever. I mean, you could probably just about work in a thunderstorm. Not that I would, not out somewhere flat, might get zapped. But Now, if you want to run a big cancel coil under high tension power lines, not a problem. You can do it. Like this is just a ring. Okay, get the gist of it. Hear how quiet it is? It's still giving a signal. I'll just put the speaker closer. But you have a listen. I know professional prospectors that listen for that tiny noise with an unchattering background, just like this is at the moment. Like you can just I'll turn up the threshold. Right, that's really powering the threshold hard. But listen how quiet the detector is. It's a little bit of background murmur, but it's hardly anything. It might even be coming from the camera. I don't know where that bloody interference is coming from. But so you hear that little woo 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 woo. Very easy to hear. Very easy. Now let's just, for instance, say let's make it choppy. Let's put the gain up. I'll put it somewhere where it's very, very choppy. I'm running too much gain for inside the house, but we'll do it anyway. Even listen to that, right? It's very, very stable. I'm not running anywhere near proper amount of gain, but I'll get the number 1 again and we'll try it. No, give it some more gain. There's about a quarter gain. Just starting to tickle it. I'll just put this on normal mode too. Okay. I've got a lot of filtering on the voltage leads that control the gain of the variable amplifier. Now I've gone up a little bit over half and it's got choppy. So I'll bring it back. No, I did put it into normal mode too. Okay. There, but it's in the noise. Put it back into enhance. Yeah, as soon as you bring the noise up, it starts having an effect on the signal. So bring it back down, it's nice and quiet. But out in the field, this detector is an absolute champ. It goes really, really well. But the trouble is, whatever the noise is in here is not allowing me to show the full capabilities. Now, next point. What if I got this one here, Mr. No Ears, right? Mr. No Ears. And I put those new input stage components into it. Now, this has just got the front end done, but not the 4 FETs that I've changed in the other one over there. So I'm just thinking, because that one had really good sensitivity, the standard, and that one also, it had less noise. And I've got my theory on why these detectors are noisy, and you can make some of it disappear by working on the internals, which it's quite funny. Not even any filtering is, well, it's sort of filtering, but not filtering in the true sense of the word. But by reducing the internal fluctuations, right, you can decrease the external fluctuations because it's a mixing effect. And yeah, I'll leave it there. I'm not going to go into too much technical detail because it's probably commercially sensitive to a degree. I'm just thinking because I think in a few videos ago I said there's something coming out. I heard on the grapevine there's a really new fantastic detector on the horizon, and it will be coming. It will be coming, and the people I know who are involved in this project know a lot about what I am talking about and doing a bit of demonstration on. But I don't want to go into too much detail of what I'm using, where I'm getting it from, because a lot of that stuff, it's all signed up under non-disclosure agreements anyway, so no one's allowed to say anything. And that's where we are. We can, or I'll change it to I can make these old detectors, right, really good. The old noisy detectors. And I've proven it. I've been doing these for all around the world for many prospectors for many years. And it just gets better and better and better as we have access to new componentry. And I've stuck my head into countless books. You know, it's a pretty dry subject, but when you start investigating the internal structures of various MOSFET and FET topologies, and you start experimenting. What a dry subject that is. That's like as dry as an old biscuit, that is. But I've been suffering reading up. Today I was doing more online courses on analog to digital converters. I'm really trying to suss out the real difference between the SAR types and the Delta Sigma types. I know the differences, of course. Just that the Delta Sigma ones, you've got to run a lot of oversampling to get the noise down. Then you've got to implement, because they're wideband, you've got to implement digital filtering. And there's limitations in the way that works. And also I'm probably going to bore the hell out of everyone now, but the Delta Sigma ADCs have very long latency times as well. Like the gates open and the horse should bolt straight away, but no, it's thinking about it. Oh, now it has. Where the SAR types are a lot faster and quicker, and you just better sampling. I mean, I don't know. I'm thinking about both, and also there's a limitation in bit resolution on the Delta Sigmas. Yeah, I'm leaning towards the SAR types, and the reason I am is because I can see benefits. And when I opened up that GPX 6000, I noticed that it had Delta Sigmas in there, and yeah, lots of 4053s. Very interesting. It's very. I'll give you my layman's opinion. Right, is that with the GPX 6000, it's very reminiscent of a GPX 4500 or 5000. The way it is structured in its working. That's my opinion. Okay, my opinion. See, what would happen if I actually said this is the way they do it, right? And it said something like that, it would cause an influx of legal threats, right? So I don't do that. It's an opinion, right? And like I say, opinions are allowed anywhere, anytime. So that's all it is, just an opinion. Now, an opinion, another opinion I found on the on the 7000s, the GPZZ ZZ 7000. I've been hearing some very, very strange things from people. That the detectors just this is no, it's not hearsay. I bloody tried it. It's to do with the specific ground balancing mode, right? The detector acts like it doesn't want to work, and you got to reset it. This is what I found out and tested. Was told, my opinion, that you got to go into the secondary reset menu to get it to behave, and you got to do it twice. Work that one out. I don't know. It just might be both of these two detectors I have here at the moment are both doing the same thing, and they might be just peculiar to them. But I don't know. But that's what I've been told, that there is something to do with the ground balance in specific mode. And if you just do a simple reset, it won't reset out of it. You've got to do a reset all, right? And then you've got to reset all. Then you've got to do it again or something of that nature, right? I can find out more about it by talking to some of the guys that use this detector every day and in various places. I know users who are up in Queensland, New South Wales, and Victoria, and also WA, and also a couple running around over in the US, in Nevada and Arizona, and Alaska, of all places. But I'll find out more on that. And like I say, take it with a grain of salt, but test it for yourself. Uh, I What I did, I put it in specific mode and I forced it into a weird ground balance mode using ferrites, and yes, it didn't like to come out of it. So until I hit the reset, the second reset all down there, and I had to do it twice. Don't know if it is repeatable. I don't know if these have got old software in these detectors. I don't know. Have they got new software in these detectors? I don't know. Do new ones with new software and upgrades don't do that? I don't know. Like I say, this is something, test it for yourself. I'm just trying to be a bit helpful to all the people who've got them. But some of the stories I heard that people were saying, oh, the detector doesn't work, it stopped working, and drove many, many hundreds of kilometres back to where they bought it from, and it was fixed in 20 seconds. That's hearsay, okay? That's hearsay. Don't know if there's any truth to it, but could be true, couldn't it? Don't know. Just saying it as it is. I get told all sorts of funny stories. Maybe they're all stories. Maybe people just pull my leg all day long. I don't know. On another note too, I'm gonna. Okay, this is a classic. This is a classic. When I went out to test the detectors, remember when if you saw in one of the videos where I said I moved the coil, I swung it a little bit too far, and it went whoa, and I said, oh, that's junk, and I said it clear as. I went back and had a look at the video, and I said, oh, that's junk, right? Because it's such a big signal. I'll tell you, when I went back there, I went and cleared it, right? It wasn't junk. And I'm saving that for another, or I'm going to save that for the next video, right? It wasn't junk. So it's yeah, it is what it is. It wasn't junk. So that's quite funny indeed. You're gonna spin out when you see what it was. It's good. It's not bad. It's good. But yeah, you're gonna think, oh my god. Well, actually, I shouldn't even say anything because there might be more of this particular thing there. And if you know where it is, you might go there and find more of them. But I had a quick look around. I didn't do the whole place. It's just too big, so I only did a little bit. Uh, okay, that's enough info on this stuff for the time being. But I'm a bit irked off. I've got that damn noise. I'm pretty sure it's a mixture of this. Oh God, I know something else I brought in. I brought the iPad into the room too. I wonder if it's that. Um, I don't know. But in the background, you can probably hear one of the kids making noise. Sound like a banshee. Now I just turn this back on just for the hell of it. I just want to see what that noise is. It wasn't there before, and it just, because I thought, oh, there's no noise, and because there was no noise, it would have made some really good tests. And now there's noise. So this is why it forces me to get out in the field and do tests. So we'll put this one on. It's got all the new bits and pieces in it. So I'll just fire this up again. But I'm just it's fairly quiet. It's fairly quiet. It's fairly quiet now. That's amazing, isn't it? It was more choppy before. It's quieter. Still a little bit there. What are we on? Enhance. Let's just see if I can pick it up in the quietness. What a difference it makes when the noise goes away. That is absolutely stonkering. And I had that on normal mode as well. So whatever the noise is, whatever the noise source is, it starts up and stops. It could be anything. It could even be all the solar installations around this place. The sun goes over, the sun goes over, the clouds go over the sun, or clouds go between the sun and the solar panels, to be more accurate, and the inverters shut down, or the sun comes out and the inverters start up. I don't know what causes this bloody noise, but I have noticed that at night it's a hell of a lot quieter until it gets to between 6 p.m. to about 11 p.m. It gets noisy in there, and after 1 o'clock, it's dead quiet. It's dead quiet. So whatever electrical equipment is on, it's external, because I've had all this stuff here running on battery power, and I've gone and turned the mains off, right? At the box out the front, and the noise is the same. So it's being externally generated off this property. And there's not much I can do about it. It just comes and goes. So that's that. But this is working really, really well. I think it was more choppy in Enhance, but I'll stick it in Enhance. It's a little bit, the timings in the Enhance mode do produce more noise. Is it that the receiver is turning on earlier after the transmit waveform? Is it I've just changed the frequency or timing spread and it's landing on interference or not? There you go. Again, too many variables. It is full of variables. But these new parts I'm very, very happy with. And what I'm going to do next, I'm going to put these into no ears, the really quiet one, and see how that goes. And that other noisy 4500 that came in the door, I don't know how the guy could use that. That is just terribly, that's ridiculous amount of noise coming out of that detector. Maybe that one is, it could be faulty or something. I don't know. I'll check into that. But it's come for a whole new front end stage, so it might cure it in one swoop. Yeah, that's that. Have fun with your detectors. I have also played around with. I'll turn that off because it's annoying. I also have um, done some more mucking around with the 6000, and I did say that it was a very, very well designed detector, as in there was no power supply leakage that I could detect. But I have found something to improve its performance, right? And I actually had to look at what I was doing with the other detectors and forward think onto that design for the GPX 6000. And I think I'm pretty sure I can get it to behave a little bit better. There's something I discovered that you would probably think that wouldn't have much effect, but it does. So what I'm going to do, I'm going to do a little bit more. I want to get these detectors back to their owners. The 7000's going, one 7000's going back on Friday afternoon, and the other 7000's going back on Sunday evening. So I haven't got much more time to play with those detectors. And the other one, the person who knows, up there in Queensland, I'd really want to do something to your 6000, which is positive, rather than just say, "Oh, I can't do anything," and leave it. I actually think I can do something really good to it. So I'm going to do it. I'm going to test it, and I'll get that back to you as well. You can do some tests up at the something or other river up there. Yeah, that's that. Anyway, it's like, God, that's a bloody waffle and a half. I nearly waffled for an hour. But there's a lot of things happening. There's new detectors on the horizon, right? And I don't know how far these detectors are. Everyone's going to find out. I'll make it known when they're available, right? But they're going to be an absolute smasher of a design, all right? Yeah, I better not say too much about it. I will get into trouble. But yeah, that's not an opinion, by the way. It's the bloody truth. And yeah, that's where we are with everything. Someone out there, if you got a six, if you got a the GPZZ 7, can you try and lock your detector up in specific ground balance mode and try and flick into a normal or difficult mode or whatever it may be, and just see if it comes out. Just tell me what you're finding out, because I want to know. Like I say, I want to see if this is one off, a two off, or it just happens. Like I say, I don't know. I really don't know. And you know, um, I could go out and go for a big long drive up to hot ground, and I can go and do it and record it all. But I'd rather, so if someone can just, who's already out in the field, can just go bang bang, here, check this out. Yes, it does it. No, it doesn't. Just leave it in the comments. Um, it's very helpful. It makes detectors better, and everyone benefits if we have better detectors. You know damn well that the other companies all watch these videos. I'll tell you that right now, they certainly do. And people out there will be taking note, because I've said stuff in videos in past years and it's turned up in newer detectors, believe it or not. So that's where we are. That's why I'm a little bit pulled back on some of the information on how to do things in the detectors. Right, I'll show you the end result. I'm not going to go into great detail saying, "Oh, do this, do that," because there was a time there where I had people ring me up all the time. oh, oh, can you tell me can you tell me how to do this? Can you tell me how to do that? And I go, no, no, oh no, I'm not doing it commercially. I'm just doing it for my own detector, right? My own detector was exact words. And then I see it advertised in the back of the Gold Gem and Treasure that they're trying to offer that to everybody. So go and well and truly get well and truly to people like that. It really gets me that. So I don't talk to these people anymore. They just go straight off. They're on my burn list. I want no interaction whatsoever. There's been a couple that have done that, and that just really, really like you do all the hard work and they just want to steal it. Nah, doesn't happen anymore. You know, like I say, I'm taking a leaf out of Minelab's book on the GPXs. I grind the numbers off everything and I put white paint over it. So monkey see, monkey do, and that is why Minelab did it, to stop the knockoffs, stop the Chinese copying, and now because of the new detectors with their you know their field programmable grid array ICs and that, you can't hack those and you've got no idea what's going on. So that makes the knockoff crowd sit there with their mouths open going, nah, can't do it, can't get into that, can't copy it, don't know. So, it's made it very, very complex. Even the act of putting handshake chips in coils also reduces anyone making a knockoff detector. Um, well, you could make it all look the same, but it wouldn't perform the same. And you can stick any detector coil on it, but the actual technology changes we're seeing now is to prevent um, that country that Donald Trump was so vocal about doing knockoffs, because it is. I'm just astounded. It's just open slobber. No one cares. It's just ridiculous. Go and buy something or other on Alibaba. They're there. I don't know why they're allowed to be sold, but they are. Anyway, and by the way, they're not made properly. I will throw that in. So if you do buy something off Alibaba, be a bit wary if it's a knockoff brand. If they're saying it looks like something we all know. If it looks like that, if it looks like that, it's not that. It is. It can be made to be that, but it's not, because those people love cutting costs and putting cheap parts in. So that's the failure there. But yeah, if you're going to buy a detector for the time being, get a proper, you know, get a proper Minelab. The reason being, look, you know, I'm not a, I'm not affiliated with Minelab. I'm not affiliated with any of those detector companies out there. I don't care. I'm not going to go and promote their product. I'm not getting a dollar for it. I just don't care. I am what I am. Like, if anyone out there, if you want to send me something, like say it's a new product for detectoring, that's a good word, or anything like that, I'll analyze it and I'll tell you the damn truth about it. I will, investigate it, test it, whatever, and say it as it is. And if it's a piece of, you know, proverbial, and it should be in the dustbin, I'll say so. If it's the best thing since sliced bread, I will say so. It just tell the truth on stuff, and nothing bad can happen in most cases, unless someone gets a bee in their bonnet about the truth upsetting their sales. But that's enough. That really is enough. I've said too much. I've got another 50 seconds for an hour. So yeah, yibbida yibbida. That's all, folks. Catch us later. And watch the next video because it's going to be quite funny. Catch us.